Hey guys, what is up? This is Austin from the Crypto Gym. In today's video, I want to do a little longer format video, and I wanted to work on this Ethernaut challenge. If you guys aren't familiar with Ethernaut, they're a lot of fun. They teach a lot with contracts and smart contract security and making sure your contracts are secure. So in this particular one here, we have a coin flip that's happening. And basically our job is to do 10 consecutive guesses in a row that are the correct coin flip. So I have to guess the correct coin flip 10 times in a row. And this is to make sure, I guess, that you can't just guess the answer. Like if it's 3, you could probably get lucky and guess it. 10 times in a row, you're probably not. You probably figured out a way to crack this contract, and you're not just guessing at that point. So let's just kind of go through my thought process and kind of how I go about doing this contract. Of course, I already beat this a little while back, but I'm going to kind of explain it the way I thought about it, and hopefully this makes sense here. So let's go ahead and get a new instance. We're going to approve the transaction through MetaMask. Confirm. So I went ahead and opened up Remix, and our transaction went through. So let's go make a new file here. We're going to call this CoinFlip.sol, and we're just going to go ahead and copy all this into a file. Copy, paste. So what we're looking at in this contract right off the bat is all this logic here really isn't that unique. What I can do is I can make another contract and have it have this same logic, and it would determine the same outcome as with this contract. So I'm going to use another contract B, to determine the outcome, and then plug that into the guess right here, and that should give us the right answer. So let's go ahead and make another file. CoinFlip, we'll call this what? Coin hack maybe, .sol. And we can keep the same pragmaticity. And then what we'll call it contract coin hack. Just like the file name. And then we'll open it up. Cool. Now what we're going to do is we're going to import the original CoinFlip file into this CoinFlip.sol, and this way we can call functions on this contract from this contract here. All right, so first up here, let's go ahead and make a CoinFlip. We'll call it CF for short, and we'll make it public. Why not CF? And let's make a constructor, and we'll set CF equal to the address that we got when we got our new instance. So instance address, that's what we want from there. We're going to say CoinFlip at this particular address from there. So now anytime we call a function on CF, so if we say CF.flip, it's going to call this contract, this function on this address from here, the instance that we're looking at. All right, hopefully that makes sense here. So now let's build a new function here. We'll say function, if I can type properly here, function. We'll call this flip hack, make it public, and we'll open this up from there. So now let's go back to this coin flip here, and let's go line by line in this function. Let's see if we run into any issues from here. So first up, let's copy this. uint block value. Move that over, format that. Is equal to block hash block.number -1. That's pretty, nothing particularly special about that there. Now we have this if last hash equals block value revert. I'm going to skip over this line for right now. If we run the issues, we can come back to this line, but right now I'm just going to kind of skip over it. I'm going to skip over this line too because we really don't use that last hash again. This is just for making sure that we don't have the same as the block value. So I'm going to copy the rest of this, and let's paste it right there. And let's format it up a little bit. And we can see that some of this logic here is more particular to increasing the amount of guesses, or increasing the consecutive wins, I should say, rather than trying to send a guess to this function. So we really have, this is our logic from here, right? This is really what's important. So from here, we can see that we're dealing with increasing the consecutive wins or setting consecutive wins equal to 0. This logic isn't really necessary to this particular function from here. So I'm going to go ahead and get rid of this. And the only other issue that we're running into is the factor. Now we can assume that this factor stays the same because there's no other function in here to change the factor number, right? Factor only is a factor when determining divided by the block value, right? So I'm going to copy this from here, and I'm just going to paste it right in this contract from here. Cool. So now we have this function from here. It's kind of stripped down. It's kind of bare bones. What we can do now is we can say cf.flip, and it's going to take in that guess. And where do we get that guess from? We get the guess from side right here. Side. And we're going to go ahead and save this. Let's go to our deploy. Let's make sure we're in the injector provider MetaMask. And then what I'm going to do is I'm actually going to switch to CoinFlip really quickly here. I'm going to copy this address. I'm going to load this contract here. And in this way, we can see the consecutive wins here. We can look that up very quickly if we wanted to, just as a reference. I'm going to go ahead and collapse this back down. I'm going to switch to the coin hack, and I'm going to go ahead and deploy this contract. And we're going to approve the transaction through MetaMask. And it looks like it went through pretty quickly here. So now what I can do is I can call this flip hack function. It says pending. I'm going to approve the transaction through MetaMask. And it looks like it went through. And if we drop this down here, we should see our consecutive wins increase to 1. Let's do it again to make sure we just didn't get lucky. And we'll call this function for a second time. Confirm. And taking a second here. Back to CoinFlip. And now we should have 2 consecutive wins. And I'm going to keep going through this here. It's going to take a second, of course. Now, if we do see this error, we can just cancel the transaction, wait a minute, and then try again. And confirm. All right, so I think we made it to 10 here. We're at 9. Let's call it. We're at 10. So that means that we cracked this contract. Let's go ahead and submit the instance. And let's see if we beat the level. Confirm. So it looks like we went ahead and beat this contract. We cracked this contract. You guys did fantastic. I'm proud of you guys. If you guys learned anything at all, be sure to give me a thumbs up, comment down below, and subscribe. And I'll see you guys in the next video in the crypto gym. See you guys.